Hi everyone, and welcome back to the CAD/CAM course YouTube channel. In today's tutorial, we're going to model this potentiometer fader knob. Now, potentiometer fader knobs are commonly used in audio equipment and lighting systems. They help control volume, brightness, or other signal levels. You'll find them in mixing desks, guitar amps, lighting consoles, basically anywhere you need smooth, linear control. As always, we'll break the entire model into simple steps and build it piece by piece. And to make it even easier, I've also prepared a step-by-step PDF guide. The download link is in the video description if you'd like to follow along. Now, before we dive in, this is a great time to pause the video and try modeling it yourself using everything you've learned so far. And if you get stuck, no worries, just come back, press play, and follow along with me step by step. All right, let's begin with step one. If you'd like to support my work and help me continue making high-quality FreeCAD tutorials, consider buying me a coffee on Ko-fi. Your support, no matter how small, goes a long way in helping me dedicate more time to creating detailed, beginner-friendly content for this community. You'll find the Ko-fi link in the description below. Thank you for your support. It truly means a lot. The step one is to create the core body shape of our knob. So first, let's switch to the Part Design Workbench in FreeCAD. Now, we're going to draw just half of the profile and then mirror it later. When it asks you to choose a sketch plane, select the side plane, that's the XZ plane. Next, grab the line tool, click right on the origin point, and drag out a horizontal line toward the left side. Now let's draw two arcs. Select the Arc by Center tool, click somewhere along the vertical axis to set the center, and draw a rough arc just like this. With the same tool still active, mark another center point, like here, and draw a second arc that overlaps or cuts through the first line and arc slightly. Now, let's define this sketch more precisely using dimensions. Select the center of the first arc and the origin point. Set this distance to 22 millimeters. Next, click on the arc itself and give it a radius of 16 millimeters. Now for the second arc center, set its horizontal and vertical distance from the origin. Both should be 3 millimeters. And give this second arc a radius of 10 millimeters. Now, grab the trim tool and clean up any extra lines outside the desired shape. To fully constrain the sketch, hold Control, select this lower point and the vertical axis, then click on the coincident constraint. The sketch is still under constrained. Now, test the sketch, try moving some points. If they move, it means we still have some degrees of freedom. This point is moving, so it is under constrained. Select this horizontal line and apply a horizontal constraint. At this point, the sketch should turn green. That means it's fully constrained. Next, select the entire sketch by dragging a box around it. Then click the mirror tool and choose the vertical axis as the mirror line. Now you'll see the other half of the shape, but it's no longer fully constrained. If you grab and move it, the whole thing shifts around. So we need to constrain it again. First, select this point and the origin and apply the coincident constraint. Then select these 2 points and apply another coincident constraint. Then select the 2 top corner points, then the vertical axis, and hit symmetry. Repeat the same for the 2 bottom corner points and apply symmetry again. Once again, the sketch should turn green. Click Fit All to zoom to the entire sketch. Now, let's clean up the view a bit. Click the eye symbol to hide the constraint label so the sketch looks clear. And that's it. We now have a clean, fully constrained, closed profile. Close the sketch and click Fit All again to center the view. Now that the base sketch is complete, let's convert it into a 3D solid using the Pad tool. First, make sure your sketch is selected in the model tree or directly in the 3D view. Then click on the pad icon in the toolbar. This will open the pad parameters. In the pad settings, check the box that says symmetric to plane. This ensures that the extrusion extends equally on both sides of the sketch plane, keeping the model centered. Now, change the length of the pad to 11 millimeters. Once everything looks good, click OK to apply the pad. You should now see a solid body formed from the sketch, and that completes this step. Let's move on to the next one. In this step, we'll add the side groove by sketching on the XZ plane and using the pocket tool. Back in FreeCAD, click on Create New Sketch. When prompted to select a sketch plane, choose the side plane, that's the XZ plane. Once the sketch opens, click on the View Section tool to get a better view of the sketching area. Now, select the External Geometry tool and click on these two edges to bring them into the sketch as references. Next, select the Line tool and draw two straight lines forming a V shape. Grab the Dimension tool and add a length of 1.25 millimeters to each of the lines. Then, using the same Dimension tool, add an angle of 50 degrees between the two lines. Now, we need to position the V shape. Use the Dimension tool again to add the horizontal distance between the corner of the part and the center of the V shape. Set this distance to 1.5 millimeters. At this point, the sketch is fully constrained, but it's still an open sketch. So let's close it. Select the Center Arc tool, click on this corner point as the center, and draw an arc that connects the ends of the V shape. Now, constrain the arc, hold the Control key, and select the arc's endpoints, then apply the coincident constraint to both pairs of points. You'll notice the sketch becomes under constrained because the previous 1.5 millimeter dimension was lost. No problem, just add that dimension again between the V shape and the corner. Now the sketch turns green, which means it's fully constrained. Go ahead and close the sketch. Back in the Part Design Workbench, select the Pocket tool. In the Pocket parameters, check the box for symmetric to plane. Then set the pocket type to Through All. Click OK to confirm. The groove is now successfully created, and that completes this step. Now that we've created the groove, the next step is to pattern it around the top surface. But here's the catch. The top surface is curved, not flat. So using a linear pattern won't work. Instead, we'll use the Polar Pattern tool, but with a small trick. Let's walk through it step by step. In the Part Design Workbench, go to the Model tree and select the pocket operation that created the groove. Then click on the Polar Pattern tool. Now, to make the polar pattern, we need to define the axis around which the pattern will rotate. That axis should be the center axis of the top circular arc. But if you open the axis dropdown, you'll notice that this specific axis is not available to select directly. So we'll have to create a custom reference axis. Here's how. Click on the Create a Datum Line tool. In the datum line parameters, under reference 1, select the curved edge of the top surface, the circular arc. FreeCAD will automatically generate a datum line perpendicular to the arc's plane and passing through its center. Click OK to create the datum line. Now go back to the model tree, select the pocket operation again, and click on the Polar Pattern tool. This time, in the axis dropdown, select Reference and choose the datum line we just created. Now adjust the pattern settings. Set the mode to Angle and Occurrences. Change the angle to 11 degrees and set occurrences to 7. Then click OK, and that's it. The groove has now been successfully patterned across the curved surface using a polar pattern. This step is complete. Now, as per the drawing, the next step is to add a chamfer to the base of the model. Rotate the model so that the bottom face is clearly visible, Then, select the bottom face of the model. Now, click on the chamfer tool from the toolbar. In the chamfer parameters, set the chamfer size to 1.5 millimeters, and click OK. That's it. We've added a clean chamfer to the base. Step complete. Now, as per the drawing, the next step is to remove material from the bottom face of the knob. The specified pocket depth is 4.5 millimeters. So let's head back into FreeCAD. First, rotate the model so you can clearly see the bottom face. Now, select this bottom face by clicking on it. With the face selected, go to the toolbar and click on the Pocket tool. You'll see the Pocket Parameters window open up. In the pocket type, keep the default dimension mode selected. Now set the length or depth of the pocket to exactly 4.5 millimeters. Once everything looks good, click OK. This step is now successfully completed. The next step is to create the projected hole feature that allows the knob to properly fit onto the shaft of the potentiometer. All right. Back in FreeCAD, rotate the model and select the inner face of the previously created pocket. With this face selected, click on Create New Sketch. Now, to get a better view of the sketch plane, click on the View Section tool. This gives a clean cutaway view, making sketching easier. Next, select the Centered Rectangle tool and drag out a rough rectangle from the origin. Now grab the Dimension tool and set the length to 4 millimeters and the width to 1 millimeter. That creates the inner cut. Now let's draw the outer profile. Again, select the Centered Rectangle tool and draw a second rectangle centered on the same origin point. Grab the Dimension tool again, and this time add dimensions between the two rectangles. Set the distance between their widths to 1 millimeter, and the distance between their lengths also to 1 millimeter. Once all dimensions are added, the sketch should turn green, indicating that it's fully constrained. Now go ahead and close the sketch. Back in the Part Design Workbench, click on the Pad tool. In the pad parameters, change the pad length to 5 millimeters. Click OK. And that's it. We've created the projected slot feature. This completes the current step. In this step, we're going to add support ribs around the whole projection. These ribs will provide extra rigidity and structural strength. Again, back in FreeCAD, rotate the model and select the same inside face. Click on Create New Sketch. Now, grab the External Geometry tool. Carefully select all the inner and outer edges. This will help us align the support ribs precisely. Next, click on the View Section tool to activate the sectional view. Now, select the Cornered Rectangle tool and begin drawing the support rib a small rectangle extending from one side to center. Once the rectangle is drawn, grab the Dimension tool and set the width to 1 millimeter. Now, make this rectangle symmetric about the central axis. Repeat the same steps for the other side, draw a matching rectangle, add dimensions, and make it symmetric. Now, do the same process to draw the two remaining ribs so that you have one rib on each side of the projection. Make sure to fully constrain each rib, just like the first one. Once everything is fully defined, the sketch will turn green, indicating it's fully constrained. Now, close the sketch. Back in the Part Design Workbench, click on the Pad tool. In the pad parameters, change the pad length to 4.5 millimeters. Click OK. That completes this step. In this step, we'll add small fillets to smooth out all the sharp edges on the model. This not only improves the appearance, but also helps in avoiding stress points and gives a more 3D print-friendly shape. Back in FreeCAD, go to the Part Design Workbench and click on the Fillet tool. Now, carefully select all the top edges of the grooves on the knob. These are the edges running along the top surface where the finger grip indents are formed. With those edges selected, change the fillet radius to 0.2 millimeters. Once that's done, click OK. Next, let's move on to the side edges of the knob. Pick any one of the side edges, and again click on the fillet tool. If FreeCAD suddenly shows a weird or broken preview, this often happens because the default fillet radius is too large for small features. To fix this, simply reduce the fillet radius to 0.2 millimeters and press Enter. Now, rotate the model to the opposite side and select a similar edge. Again, apply the fillet with a 0.2 millimeter radius. Once all the key edges are filleted, your model will look much cleaner and more professional. That's it. This step is complete. In this step, we'll model a small groove-like slot on the side of the knob. This is where the color indicator strip will be inserted. First, reorient the model to the isometric view. Now, click on Create New Sketch. When prompted to choose a sketch plane, select the side plane. To make the sketch easier to work with, click on the View Section tool. This will give you a better view of the sketching surface. Next, select the Centered Rectangle tool and draw a rough rectangle, making sure its center lies on the vertical axis. Now switch to the Dimension tool. Set the width of the rectangle to 1.3 millimeters and the height to 1.2 millimeters. At this point, the rectangle is fully shaped but not yet positioned. So activate the External Geometry tool, click on the corner arc at the top of the knob. This will be used as a reference. Now hold down Control, select both the reference arc and the top horizontal line of the rectangle, and apply the tangent constraint. The sketch should now turn fully green, which means it is fully constrained. Close the sketch. Next, click on the Pocket tool. In the pocket parameters, check the option Symmetric to Plane. Then, under Pocket Type, change it to Through All. You'll now see that the groove has been cut all the way through the knob, but we're not done yet. We need to extend this groove downward on both sides. So let's create another sketch. Select the top face of the groove we just created and click on Create New Sketch. Now activate the External Geometry tool again and bring in the necessary reference lines from the model. Next, grab the Corner Rectangle tool and draw a vertical rectangle extending downward, starting from one end of the groove and going slightly below. Do the same on the other side, drawing a second rectangle. Now grab the Dimension tool and set the height of each rectangle to 1.2 millimeters. Once both rectangles are dimensioned, the sketch will turn fully green. Now close the sketch. Select the Pocket tool once again, and this time change the pocket length to 3.3 millimeters. Click OK, and that's it. You've successfully created the groove slot for the color indicating strip. In this next step, we'll create the color indicator strip using a multi-body part design approach with the help of the Shape Binder tool. But first, let's make our main body visually distinct by changing its color to something close to black. So, under the model tree, select the main body, then go to the View tab. Under Object Style to Shape Appearance, click on the color box and change it to a shade close to black. This makes it easier to differentiate between different components. Now, before creating the strip, let's rename this current body as main body just to stay organized. Next, click on the Create New Body icon to add a new body to the project. Rename this new body as Strip, and again, change its color maybe to red, white, or anything that contrasts well with the black body. Make sure the strip body is now active. You'll know it's active when it shows a green highlight in the model tree. Now, we'll create references from the main body to the strip body using the Shape Binder tool. So rotate the model and select one of the side faces of the slot that we previously created. Click on the Shape Binder tool. This creates a reference of that face from the main body into the strip body. Now rotate the model to the opposite side select the other face of the slot, and again, click on the Shape Binder tool. You should now see two shape binders listed inside the strip body, one for each face of the slot. These shape binders are referenced from the main body and will help us build the strip geometry within the strip body. In the next step, we'll use these binders to create the 3D strip that fits perfectly into the slot. Now, out of the two shape binders we just created, let's hide the one we don't plan to use. Next, select the visible binder and click on Create New Sketch. This will place our sketch on the same plane as the binder, meaning we're technically sketching on the side face of the slot we created earlier in the main body. But remember, this sketch belongs to the strip body. It's a separate solid. Now, activate the External Geometry tool and click on the binder's lines. These will serve as reference geometry for our current sketch. Once the references are in place, grab the polyline tool and start tracing the inner profile of the shape. For the outer edges, make sure to extend slightly beyond the reference sketch. This is intentional because the strip should extend just a little past the surface of the knob for better visibility. Continue sketching the full profile, and finally, close the profile by connecting the last point to the starting point. Now, switch to the Dimension tool and set the offset between this vertical edge of the sketch and the reference binder to 0.3 millimeters. Do the same for other offsets, maintaining a 0.3 millimeter gap around the outer perimeter of the strip. Once all dimensions are in place, the sketch should turn green, indicating it is fully constrained. With that done, go ahead and close the sketch. Back in the Part Design Workbench, make sure your new sketch is selected. Now, click on the Pad tool to extrude the shape. Looks like the active body selection is lost. You might see a pop-up asking you to select the active body for this operation. You can either select the strip body directly from the pop-up or just cancel it for now. Instead, go to the model tree, right-click on the strip body, and choose Toggle Active Body. An active body will be highlighted in green, confirming that it's ready for operations. Now, with the correct body active and the sketch selected, click the Pad tool again. In the Pad Parameters window, set the length to 1.3 millimeters and hit Enter. This will extrude the strip out from the slot. You can now unhide the main knob body to check how well the strip fits into the slot. It should be perfectly aligned with a slight offset. Next, let's take care of the sharp edges on the strip. Select the Fillet tool, then click on the outer sharp edge of the strip. Initially, try a fillet radius of 0.2 millimeters, but if it feels too subtle, go ahead and increase it to 0.3 or even 0.4 millimeters based on the look you want. And that's it. Your fader knob model is now complete and ready for export. You can now export the model as an STL file and send it to your 3D printer. And that brings us to the end of this tutorial. If you found this tutorial helpful, please consider liking the video, subscribing to the channel, and turning on the notification bell so you don't miss upcoming lessons. If you'd like to support my work and help me continue making high-quality FreeCAD tutorials, consider buying me a coffee on Ko-fi. Your support, no matter how small, goes a long way in helping me dedicate more time to creating detailed, beginner-friendly content for this community. You'll find the Ko-fi link in the description below, or use the Super Thanks feature right below this video. Thank you for your support. It truly means a lot.